Okay, hello everyone, and welcome to episode 5 of the 3D Print Doctor. We've got a couple of people online, and the rest of you will be watching this as a recording. Do a quick welcome to country and acknowledge those elders past, present, and emerging, and anyone from Aboriginal descent or for that is listening in the lands of which you are listening from now or in the future. So today we're going to be looking at quality or speed printing, being able to sort of manipulate how things get printed. And it's one of the areas which comes into effect when you are trying to either print something off nice and quickly, just because you're iterating, repeating, and you're trying to sort of prototype something up to a solution which will work for you. And so you just want to get a quick print, size it, make sure it fits, do some measurements, and then move on. Or you have reached that point where you've got the perfect size, you've iterated a number of times possibly, or you fluked it and got it right the first time, and you want to get the best quality print out of your 3D printer. So we'll kick off with it. You need to be in Flash Print. We have had a couple of people who have got their new Flash Print software, the adventurers, and the printers, sorry, and have found that the information on the T4L website is a little misleading. There is a reference to a Flash DL print for BYOD. That particular print slicing software is for the Hunter resin printer from FlashForge and will not work with your Adventurer or Inventor. So get the Flash Print software, but remember that the advice for this when it was sent out, the Adventurer 4, is that you deploy the Flash Print software from UDM. It will be the latest software. It is hard keeping up because they do regularly patch it. And when we all end up being in-tuned, we will find that the software will update automatically. It'll make things a lot easier for us. So what I've done is simply just loaded up a particular object that we've got on the screen here. This was a little power button cover that I made for the mini PCs for a school that was trying to stop one of their kids from persistently turning the mini PC on and off because they found it interesting to touch the button and turn it off. I've just put this cover on, which means you've got to put a pencil inside it to try it. They're testing that out shortly, and we'll see whether it actually works or not. But we're going to go through and have a look at how I would actually slice it. Before that, I will look at how I would orientate it. One, I would never print it in this orientation because this area here at the back is going to need support. So I twist it or throw it around. The perfect way to print this for avoiding issues about supports would be to spin it along the y-axis. So if I spin that through 90 degrees, the best thing about this is I've only got this, let me get it there. I've only got this tiny bit up here to support, and the FlashForge printer will do that really easily. Now, the problem I have is here, this will be done in layers. So the layers is like looking at it as a piece of slate, and you get shear planes along those layers. There is a way to actually get them to bond better by putting it into an oven at about 100 degrees for, say, an hour, and it will send the polymers will cross-link themselves, and you get a bit of added strength if you're really trying to get the strength. So I wouldn't print it in this way. Plus, the higher you print, the longer it takes to print. So the way I would print this one would simply be to print it in this orientation here. Yes, there is a bit of a bridge across the top here, but because the Flash Print does bridging quite well, there's very little spidering or drooping of the initial layers. It tends to bridge quite well, and there's a function within the slicing which allows for that. And this particular holes like this print really well. You will get the tiniest little feathering across the top here, but otherwise virtually perfect. The way this would be the best way to print it, or even to flip through 180 degrees, it'll still print nicely. So let's go through the slicing. So if I was iterating this, and as I did iterate it about 5 times before I got it right, it was a bit slow this time around, you will find that there's a number of ways that you can actually speed things up. I will state straight up, I'm going to get out of that so I can move this to the side. So you've got something else to look at, and we'll get on with the slicing. Okay. Can you see that reasonably well, Stu?
Yeah, if people maximize their screen, it seems to read quite well.
Yeah, even if you get rid of the bit on the side, put it out there, and then you should be able to see it nicely.
Yeah, there is a button that you have up the top in Teams that says View, and you can choose Focus on Content.
Yeah.
And that will get rid of everything except what you're sharing.
Great. Do that one. That'll give them a lot better screen imaging. Thanks for that. Now, I will state straight up front that 90% of the times when I'm doing a print, I just go with the default settings, except for raft, which I turn off 90% of the time. If I have a particular object that I'm trying to print which needs better adhesion to the print bed, and I'll drag one in quickly to have a look at that. This one here is a perfect example. I think I've shown you this before. And if you have a look at that, it's got a very, very thin edge touching the bed. So this could get knocked off because there are lateral loads as it's printing because the filament is viscous, and so it does tend to rocket. That could very easily detach about halfway or further up. So I would put a brim on this, and a brim is all you need for this particular one. Here's the other example that we looked at last week, the little elephant. And come in here. And the elephant's feet are probably almost enough, but if you have a look here, there's only these two little sections. This is the one real thing that you really find you start doing. Look for the blue patches, and you might have a different default color, but these are the bits that are actually touching the print bed. You've got nothing touching the print bed, and unless you get good extrusion and the filament comes down and touches the bed, you will find you'll have a bit of a problem with the elephant. We already know that you're going to have to put supports on the elephant because his trunk's just not going to get printed because it's hanging in midair. So there's the reason you will actually do that. And I would again use brim on that one. So let's look at, I will do them at the same time, quality and speed. And we'll go through them in order on the menu when you get into the slicing software. So if I'm looking at here, there's nothing to change on the general printer page here. You've got your PLA, you've got your Adventure 4 series. You should have selected that down on the left-hand bottom to make sure that you've got the Adventure 4 selected, and your nozzle size is 0.4. Note that you can get a 0.6 nozzle if you buy an extra nozzle, and it I think is also, I think there's a 0.6 240 and a 0.6 265 degrees Celsius option available. And again, if you're wanting quick prints, a 0.6 millimeter nozzle will really spit the filament out quickly and decrease your print times. Really good for draft printing. But 0.4, there's ways we can get around it. So we leave all of this. We really don't want to muck around with it. We don't have to change. So let's go down to the general menu. And I've listed these in the actual video notes that are going to appear here. So you can actually go through this and follow it through. They'll give you 90% of what we're looking. The very, very first thing that you can really work at in terms of changing the length of time it takes to print something, because it does take a long time to print, the two areas that generally get changed are your layer height and infill. They're the two main areas that you can change super easy to actually decrease the amount of time. So if you want to actually get a quicker print time, you can actually put your layer height, for example, all the way up to 0.4. Okay, so a 0.4 millimeter layer height is the same height as the diameter of the actual nozzle. So you're basically printing a circle as it goes down, and it's laying that down. There's enough fluidity in the filaments to actually adhere to each layer. 0.3 is probably a good size, but you will notice that the layer heights are basically referencing, or they're equivalent within fractions of the diameter of the nozzle. So a 0.4 is a good size to print and a 0.2 is a good size to print. You can print at 0.3, and if you're having a look at this, you'll notice that the 0.3 first layer height is there for a reason, because what it's doing there is that it's actually saying, I want at least 0.1 squeezing out onto the bed to actually get a footprint and a bit of a hold into the actual print bed so that it sticks that first layer down. But the quickest way to get a really quick draft print, increase your layer height out to 0.4 of a millimeter. Everything else in here, you can increase your speeds and do some things. There is a little print speed, travel speed. Travel speed is the speed between one point to another when it's actually not printing as such. So it's not your maximum speed, 6 millimeters, but minimum speed, 6 millimeters. That's the first layer speed. Always have that down. I used to go down to 10. 15 works with the Adventurer nicely. And so you're looking at these little things here that will make a big difference. Base print speeds, I would leave your print speeds. You can try and ramp it up, but I would be very, very wary about increasing your print speed at any point in time, just to save yourself some time. And fail prints is the main thing you're looking at. So we can go 0.4, that will increase it. If, however, you want to increase the quality of your print, you can go down to a 0.1 millimeter height. That is probably the best way. It won't extrude as much filament. It'll lay it down in nice little thin layers, giving you very, very fine layers. And those lines get to a point at 0.1 of a millimeter where they start to become pretty hard to see but with the naked eye. You can see them, but you're really getting a nice smooth finish at 0.1. Be very aware that a difference between 0.2 to 0.1 layer height is literally doubling your print time. So if you've got a 1 hour print time on an object or a model, it will take 2 hours at least to print those layer heights. There's a lot more movement that goes on, and it is a really good way to improve the quality, but your print times will blow out severely. Now, let's move down to the next level. Now, what we could do actually, and that might be a clever one, let's do a 0.1, and I'm going to slice to see how long it would take to do this particular object slicing at 0.1 to give you some comparisons. So that's going to go in here. Let's slice preview. That's going to take 2 hours and 12 minutes. Now, let's start slicing this and change this at 0.4. So a super quick draft time, and let's slice it. Goes up here, and now we're down to 39 minutes. So that's a massive difference from 2.5 hours, I think it was, down to 39 minutes. It's less than half the time, and so it should be. It's doing a really rough type print to get it done nice and quickly. So that straight away is going to give you a nice quick time. Let's look at shells. Now, here's an interesting one that I actually tweak on most of my prints. Shell count is a standard count. Now, that is the outer and an inner layer, giving you a width of approximately 0.8 on the outside of each of your prints. If you have an object which is, let's say, 10 millimeters thick, it will actually do an infill, and we're going to get to that next. This is the little skin on the outside before you get to the infill. Now, the infill is a number of shapes, and you'll see those in a minute, hexagonal and all sorts of different weird and wonderful shapes that you can put on the inside, because 3D prints are not solid. Now, I now do something weird. Even though I want to get a quick print, I actually go up to 3 layers. The reason I change it to 3 layers, if I'm printing a near as complete print, this is one of my finished prints, I will go to 3. 3 layers stops any of the vertical infill lines showing on the outside of your print. You will start to see this as you get more and more into 3D printing. I would stick with the default for a while, but when you want a quality print, and if you start to be able to see the areas where the infill is joining the external shell of your 3D print, increase your shell count to 3, and that will virtually get rid of any of those little lines that start to form on the outside due to the infill surface area touching it. That's a cute little one to work on. Everything else pretty much stays the same, but that's a cute little trick to increase the quality. Increase your shell count to 3. 4 is a waste of time. 3 is plenty. It doesn't add a huge amount of time, but it does add to the overall print time, but not significantly. So worthwhile looking at. Now, infill, as I said at the start of this, is probably the main area that 99% of people will go to really speed up a print. Now, the fill density of 15% is the one here that you're looking at. The fill density is an interesting one, being only 15%. Most of the time you'll find it's around about 20 on a lot of other slices. 15% is surprisingly dense, I would say. Let's call it that. I'll slice up in a second and show you. So if I slice this at the moment, and let's go back. What have I done? I've got a 0.4. I'm going to go back to 0.2. Let me type it in because that's our default. And then I'll go to infill, and I'm going to just stay with my defaults. And I could go over here and just go, where's my, there should be an area which says I can restore defaults. I could restore defaults easily there. Let's go slice, and let's just have a look at the preview here. I'm going to drag it over here, and let's have a look at the infill. You can actually see the infill here, and I'm going to zoom right in. Here is our infill, and you can actually see the round layers that actually get, they're a little bit more exaggerated in this diagram than you will find everywhere else. And you can start to see how it lays the circle of the hole here as well. So these particular areas here are your infill, and this is the area that touches. These are little areas that touches, and that's what I was saying about the shell. You can see the outer shell, which is the pink area, and then the green shell is the second layer. If I put a third layer, there would be 3 different colours, I think. I haven't looked at it for a long time. And here is our little infill. This is 15%. So that is quite a strong internal layer. And you will notice along these very thin areas, it's just placed every now and then. Now, if I increase the infill up, let's go back and start slicing it. I could knock that down to speed things up to, let's say, 5%. And I wouldn't go under 5%. Let's have a look at what we get with when we do 5%. Okay, now if I do 5%, here we go. Now we've got very little infill now to the point where we kind of even don't have anything over here. But these 2 shells here will be enough to support it. And you'll notice that we've got very little support along this edge here. So I could probably squeeze those with my fingers. But I'm doing a draft print. I want to knock this thing out super, super quick. Don't go less than 5%. Now, if I'm trying to get some strength, I may go up to as high as, say, 25%. I wouldn't go much higher than that. There is a funny little thing with 3D printing. A solid 100% infill does not necessarily increase the strength of something. Here we are with 25% infill. That's very, very dense. That's going to give you a very strong print. 25% is really strong, but it has also taken us out to 1 hour and 20 minutes for this particular print. If I do it at standard, it comes in at under, I think it's 50 minutes to do it at 0.2 and at 15%. So a quick way to really speed up your prints is to decrease the actual infill and go down as low as 5%. I don't think I'd go down to 0. It does it in 5% layers. You could type in 2%. No problems at all. I don't think there is an option with that, and it should slice at 2%. This will be interesting. We'll see how much is there. That's actually better than 5%. I like that. I might do this more often. It's good things that you learn when you're actually doing things on the fly. But this is actually, that structurally is quite strong compared to what it did for the 5%. So 2% might be an interesting one to try, boys and girls, and have a go at that one. So the 2 main things that will increase or decrease your time, that's 1 hour flat to do this now, so it's nice and quick, is the infill is one of the ones that I changed to start off with straight up. I'll go down to 5%. And the other one is increasing your layer height to 4. I don't do that a lot, but it is a really good way of decreasing your print times, especially when you're draft printing and you're iterating. So the next thing that you can be starting to look at is supports. You do need to put supports in. This area in the menu, I tend not to play with very much. When it comes to supports, I will come over into the support section. Can I bring that over here? I can't. And this is where I play with supports. Now, supports do add significantly to print time. And if you've got something that you have to use supports with, e.g. the elephant, and that might be the best thing I can do right now, is I might bring our little elephant over, because he'll be good to have a little bit of a test with how we can put supports in. Come over here. Right, okay, so let's look at our elephant. And we're going to actually put some supports in on our elephant. And what I might do is do a slice, a quick default slice, just to get an idea of how long it's going to take. And then we'll throw the supports in to see how much it does add. Slice preview, it's 2 hours and 2 minutes. That's easy for me. I can even remember that. I probably won't, but we'll see how it goes. Now let's look at supports. The support option that you have here are tree and linear. There is a significant saving I find by going tree, and I really like tree supports. They've only been around for a couple of years now, but they do a good job at supporting your model, especially things like the trunk, the tusk, etc. They can be a bit tricky to remove, but persist with. You can get some side cutters with very, very fine blades and they work well. Where you can tweak the supports in terms of decreasing the print time, because they do add significantly to the print time. So if I just go auto supports, go back and now start slicing, let's do it on the defaults. I'm not going to add a raft. I'm going to ignore that. You do need one. You will find here we have now got 3 hours and 17 minutes, and I can't even remember what it was before. I think it was 2 hours, wasn't it? So it's added another hour and 7 minutes just putting these supports in. So let's have a look at the supports, and I would then start playing. So let's look at supports. When I get supports like this, I start to think, well, okay, what do I really need to do? And if I look at my elephant, I really don't need these supports here. That will print that curve. So I can now go to the delete bit and I can start deleting parts of the supports which I think are really unnecessary. The fact that there's no way in the world I need a support up here, I will get rid of that. That should print. You might get a little bit of a dag. These areas here you could probably get rid of. I will leave them for the moment. The tusks definitely need some support. Again, I shouldn't need supports here. That's not going to need a support. You will need to support his tail, but really it don't need to support his bottom. That should print. Just make sure that the tail is supported. That really there doesn't need supports because it's supported everywhere else underneath. So there's a few. These little areas here, total waste of time putting those supports in there. They do nothing. You will find that the flash printer will be able to print those little curves that come up from underneath. So we can actually get rid of those. Now, this won't make a massive change to the print time, but it will mean you've got less to remove. So let's go back and do a quick slice. Hopefully everyone remembers how long it took. Let's ignore that. And slice preview. And now we're down to 3 hours. So we saved a whole 7 minutes. Not a huge amount, but it does make it easier for you later on to remove things. And I could probably get a little bit more aggressive with how I would remove things. There's a couple here that I reckon I could get rid of as well. But be careful how many you remove in that respect. To give you an idea of the difference between tree and linear supports, let's throw the auto supports. These here, you can see how many you've got. There's a lot, and there's a fair bit to print. And if I go back and do a slice on that, this will show you the difference between tree and linear supports on the slicing. It takes it out to 3 hours and 9 minutes. So the reality is there's not a massive difference between tree and linear, though I do think these are hollow when they print out. I always think I'm using more filament, but obviously it's only 2 more minutes, so maybe there isn't as much in there as I think there is. Yep.
Would they be harder to get rid of?
It really depends. This one here, if you have a look at the linear along the trunk, you've got so many more points that are actually touching. And I do find at times that the linear actually come off sometimes better than tree, but most of the time I do find tree supports come off better than the linear.
Okay, thank you.
I do find linear works with engineering type objects reasonably well, though I'd still mainly use tree. Organic objects like the elephant here, I do find tree type supports are better. So that is sort of a open-ended answer, but the best I can do at the moment, so I'll do that one. So let's move on now to supports menu. Oh yeah, I went to the support, we've done supports. Let's look at the raft menu now and see what we can do there. How are we doing for time? Oh, good, not good at all. So the raft one is here. As I've said, I will use a raft as a last support. I will try and never use one if I can get away with it. But every now and then I've got to use a raft. 99% of the time, if I have to help adhesion to the print bed, a brim is where I go to 99% of the time. So it's 1% of the time I use a raft. You will find if I do restore defaults, rafts is enabled as default. So what they're doing there is making sure that a beginner printer successfully prints most of their prints, and by using a raft you're getting that option. You're getting that better yield and more prints coming out that work. I would be going down to the advanced, is it? No, the additions and doing the raft. The brim is where I would be doing it. It's a shame that they don't have brim and raft in the same section. But the raft area here does have a number of areas where you can actually look at it. Now, this margin is the air gap that it tries to print. So the idea is that a raft gets printed and then it prints sort of a 0.5 millimeter in the air, and it's just the fluidity of the filament that is touching in that first layer, which cracks away nice and easily. So it's creating what's basically termed an air gap between your object and the raft. And it does the same thing with a brim as well. The other things that you might, bottom layers, path width, fill density, etc., are all things that you could change to help the raft print quicker. You do waste a lot of filament when you actually print a raft. Again, the reason why I go for a brim if I have to use one. So I could go down to, you do a 0.4 because you just want a real roughie. Layer heights at 0.3. There's not a lot of stuff in here that you can basically change, but you could tweak if you really want it. You're getting down to pedantics when you're trying to change these things here. I would love it so that I could actually have the ability to change the height of the raft, but you need a raft, you need a raft. Again, I said use a brim instead. So let's look at the additions menu, and we'll look at enable extrusion margins, leave all of these, wall, enable wall, and again, if you hover, you will find creates a wall around the model. Oh, okay. No, don't do that. Yeah, shell count is another one. That's a little bit like the, where was it? Shells. You've got your shells here, but this is giving you a little bit of wall brim. Where was the shell? I was down here. I just had shell. Oh, shell count to enable walls. Shell count is giving you 2 spots. I don't know why they're giving us 2 spots here. Brim is where you go. So if you need to put a brim in, put your brim in. Your 3 millimeter margin is how wide the brim is. Imagine a top hat. It's the brim that's touching. If you've got a very, very slender surface touching, e.g. that rocket cone, you may want to increase this out to have a 5 millimeter brim or foot hole to the print bed. That might be, and 1 layer is all you need because it just sticks it down and you get a really good hold onto that print bed and it will work it through. The print speed, the reason why you drop it and leave it at 50 millimeters per second is that you want it to stick. That's the whole idea of you using a brim. You're wanting the brim layer to stick so that when you actually do print your model on top of it, it can stick to the brim, which is sticking to the print bed, and you've got yourself a successful print in the end. So I tend to just leave these as normal. Brim is by default off, raft is on. I kind of turn this off, and then I just save that as the base configuration, and I turn raft on when and if I need it. Cooling, there's nothing to do in cooling. You just leave it alone, because if you don't cool it properly, you will find that you do cause issues. Now, having said that, one of the resources or tips that I put in was on using flexible filament. You do need to play with the cooling when you're using the flexible filament. So there's a whole pile of different configs that you need to change if you're going to start playing with those filaments which aren't recommended in the Adventurer 4. The Adventurer 4, it does not have a recommendation to print with flexible filaments because it uses the Bowden feed tube and it can get caught up. But the Bowden feed tube in the Adventurer 4 is a really good Bowden tube, and I've had some success printing flexible. Get yourself some experience before you go down those what I call exotic prints, because they will give you some interesting outputs and failures, and they can be expensive. When you get into the advanced menu, which is one of the last ones that we'll be playing with, I think the only one that I put in here was ironing. Now, I have only used ironing a couple of times. What ironing is pretty much what it states. It runs the nozzle heated with very, very little, if any, filament coming out over the surface that you've printed and kind of smooths it out. It sort of works on some objects. This particular object in the background here, that could get really quite smooth, but it mainly only would do this top layer here. It would have difficulty ironing out a vertical surface. So if you're after a particular, a curved surface like a half dome would get a really nice finish with ironing, because you do get steps with curved surfaces like a dome. You do get some really nasty sort of little stepped slices with each layer. You will see them. Again, if you go down to 0.1, you will you'll minimize that quite significant and get a better finish. Ironing's one to experiment with. Fuzzy skin, I wouldn't worry about fuzzy skin. These are areas where you play. Now, the enable bridge is one of those things that enables, for example, that to work. So what it does when you've got the bridging enabled there, bridging slows down the cooling fan so that it makes the filament thicker, and it can stretch it across this surface when it prints this area from one side to the other. And so by stretching it, it actually is using the elasticity and the memory that plastic has. As it cools, it'll shrink itself up slightly and get taut. Gives it a nice layer. It's a funny little clever one that came in a few years back. And there are some other slices, e.g. Cure, etc., which have got some really interesting way of never needing supports. They use a sort of little leafing system, really experimental. Don't play with it yet, but it's an interesting one there. But the bridging with the Adventurer 4 will do this sort of thing really well. Whereas in the past, 2-3 years ago, when I was doing a lot of printing, I would have had a really nasty sort of little set of dangly, stringy bits underneath this length of a bridge or an opening like this. And even to a certain extent, the holes like this, you would get little daggy spiderings under those areas there as well. So it was a little bit annoying. Let me shift this over here so that I can, whoops, point those things out as I'm going. Okay, so others is an interesting thing. There's not a real lot here in others. What did I put down? There was an interesting one in here that came up, which was dimensional adjustments. Now, one thing I have found with the FlashForge printers is they do print pretty close to dimensional size, meaning that if I build this in a CAD program, Tinkercad or my Onshape or any of those, Fusion 360, etc., if this is 50 millimeters from side to side, the printer prints it to 50 millimeters. Now, some printers don't print to exact sizing. So if you're making something like this, I didn't even measure this after I printed it, because I do find that it prints to the size that I actually model at in my CAD program. And it fitted onto the mini PC perfectly to fit the areas that I had actually measured. And I use vernier calipers. You can get super cheap little vernier calipers from Bunnings, and I think, I can't remember, there might be a set of vernier calipers. No, there isn't. Worthwhile getting if you're going to do a lot of modelling. If you're doing anything in secondary where you're trying to make something to fit another object, one that you already have, get some vernier calipers, because they will give you those measurements down to 0.1 or even less of a millimetre. They are quite accurate. But this prints quite well. But if you do find, and where you do find you need to use this, is when it comes to shrinkage of the filament. If the filament that you're using, ABS tends to shrink a little bit, you may find you need to do your X, Y, or Z. And you will find that objects usually shrink only in one direction. They will either get shorter, or they will get skinnier on the width, or they will get on the X or the Y. So you will find that you need to only change one of these and go at it slowly. 0.01 or 0.05 of a millimetre at a time will be the best way to play this. Your offsets and your Z hops, sometimes you need to change these if the machine itself does a bit of a miss with the cogs and the what are they? The belts inside them. But you're better off doing any of those not here. You're better off doing those in the actual software on the firmware on the printer itself. And that, to a certain extent, is usually a service call most of the time anyhow. So that's basically how you do your print qualities, print speeds, etc., using your slicer. Once you're here, slice it, export it, print it off, do your experimentations. Use your print slice preview to always have a look at your times. It'll also tell you pretty much an estimate on how much material you're going to use. It uses very, very little, and it's a very inexpensive way to actually produce things using 3D printers. So I don't know whether we've still got, how many people have we got on? We've still only got Brett on. Any questions?
Yeah, we've been using our printers a fair bit, but we're having trouble getting the prints off. I know we have the boss likes to use the RAF, which we probably don't need to, but yeah, like if the kids try to, they'd hurt themselves. Right.
So are you removing the print bed from the printer when you're trying to take the prints off?
Yeah, we remove the black and blue thing.
Okay. Now that should then allow you to flex it. So you can actually grab that print bend and bend it, and you should be able to then find that you can get it. Now, it's a problem when you first start with the Adventurer. It almost sticks too well.
Yeah.
At this point in time, I would be saying you as the teacher need to grab that, especially if there's a large surface touching the print bed. You do find it difficult. Get the little spatula that is in the kit and very carefully pry it. Don't let the kids do it when it's like that to start off with.
Oh, because we haven't let the kids anywhere near that.
Yeah, they'll take their hands off with it. But yeah, the first lot of prints is almost too good, but don't try and change it too much, because that will wear in time and it'll start to get to a stage where you need to clean it. Now, when it starts to get to a stage where they're not adhering, and most of that is because of grubby little fingers and the oil that you've got in your skin gets on the surface of the print bed, you will find that the print that printed and stuck like the proverbial to a blanket now peels off on you and it becomes annoying. Isopropyl alcohol will clean that surface for you and give you your adhesion back. I am finding that the 3D lac or hairspray actually makes the print bed worse. But yeah, getting them off can be tricky. Get them off with the edge of your spatula, stick it under a corner, and if you can bend it at the same time over the edge of a desk, you will find you can get it underneath and then just pry it off.
So in time, it'll get easier using the same.
It will get easier, yeah. So
one of our little resin, the resin base, like the spatula
Yep.
went right in and took a chunk out. Like that's how hard some
Yeah.
of it is to get off.
Yeah, it can get really, really hard to get off. So,
And we I did go to Amazon and got the isopropyl alcohol, and
oh, good.
I
Yep.
told the boss to put that on before we do it.
Yeah, so you don't need to use that all the time. Just use that when you find that it starts to not stick because it cleans the surface.
Also, not every time.
No.
Okay.
I wouldn't use it every time. In fact, I didn't. This was the first. Usually, you've got to either put the original way we used to make it stick was using glue sticks. That's horrid because it just builds up this horrible gunk of a layer, and then you've got to clean it off with hot water. We now use the 3D lac or hairspray is the way you get around getting it to stick. The hairspray seems to react with the Adventurer 4 print bed, and it actually makes it worse. So don't use 3D lac.
Okay.
I may change that as I use mine a lot more, and we find that it starts to work, because if it wears off to a point where I call it gecko skin is what a print bed does. The gecko can sort of let go when he wants to, but it sticks until it needs to let go. But yeah, you will find that the odd print when you start, I've had exactly what you were saying, is a big print actually broke as you were taking off because it stuck too well. Try a bit of isopropyl on it when you do that. It might just actually lessen it sticking. Got to experiment sometimes, yeah.
And if is there a way to heat the bed up without printing anything so we can try and get it off?
Yeah, there is a preheat function on the menu of the printer.
Okay, thanks.
Yep, do the preheat. And I would have to remember, is it preheating of the nozzle or preheating? Pretty sure there's a preheat of the nozzle and the bed in that preheat.
Okay.
There, that's the way to do that one. Excellent. Jason, sorry, any questions?
Thanks for putting the sword up.
Yeah, not a problem. Oh, you got the sword?
Yeah.
It is cool, the sword. Use it on your interactive whiteboards. It really is a bit of a hoot when you play with that. It's a lot of fun. Now, when you do that, you will find that some filaments just work straight off the print, and occasionally some of the filaments, they stick. So you got to break all the little sword parts out slowly. It takes a little time sometimes to do it. If you've got old filament, that tends to really spread and you don't get a good print. Good fresh filament will print that off beautifully. Have some fun. It's good. Okay, guys, we'll call it quits for today and see you next week. Now, next week, I am going to do and diverge slightly, because what I'm going to do next week is actually look at the Inventor printer and what things are happening with it, maintenance and repair, because we have a hell of a lot of printers out there that are the old Inventor. But at the same time, I'm going to be referring to a few of the maintenance hints with the Adventurer 4 at the same time, but it'll probably be 80% Inventor and 20% Adventurer for next week, but it'll be maintenance and repairs that you can do to your printers. Okay, we'll see you next week if you decide to come along.
Thank you.
Bye, guys.